Hello again, and welcome to Building 61. This is Shop 61, and I'm Robbie. Today we're going to be talking about the joiner. A joiner is the machine that we use to create our first flat face and our first flat edge. I emphasize first because we don't use this machine to do the opposing or second face or opposing or second edge. Before I go into how we use this machine, I'm going to explain how it works. For starters, we have our in-feed table, our out-feed table, and our cutter head. We have our fence, and then this lever here adjusts the height of the in-feed table. When the in-feed table is set to 0, so we'd be cutting no material off, the two beds are coplanar, and the peak of the spinning cutter head is very close to level with the beds. It's actually about 1 to 2 hundredths above, which just makes it function properly. The cut depth of this machine goes anywhere from 0 up to 1/8 of an inch. I almost never do 1/8 of an inch. That's a very aggressive cut. I usually am between 1/64th and 1/16th. The way this machine works is the piece that we're wanting to flatten, it starts on the in-feed table, goes across the in-feed table, runs into the spinning cutter head, and then it cuts off material, which I've pre-cut on this side. So we go across the in-feed table, across the blade, and then that new surface that we've just created lands on the out-feed table. So that's what it looks like when it's partway through the cut, and then obviously we would take it the rest of the way through. So it's taking material off of the bottom of our piece and the amount that we have set with our cut depth. The way I like to joint a face is to definitely use push pads on top of the piece, hold it down with moderate force, and staying on top of it while gently shuffling your feet so that you're never off balance. Steadily and evenly bring it across the blade. This way you have the push pads between you and the machine, and you have your actual piece between you and the machine, and you're never getting off balance. Once we've created that first face, we will then put that first face against the fence. The fence we have set to 90 degrees to the beds, so that if we have our face that we created against the fence, we're using it as a reference so that we're creating a 90-degree edge relative to the face. To do that safely, we'll only have as much of the blade exposed as is necessary. And this time we will not use push pads. Our front hand, we want to lock our thumb on top of the piece. That's the most important part. And then with your fingers, you want to kind of press into the center of the board so that it won't rock that way and the bottom won't come out. Your backhand, you want your thumb up on top of it. That way you know where it is, as opposed to having your thumb behind it or your fingers behind it and your hand blocking your view of your fingers. This, I feel like, is the safest way. When we're doing this edge and using this reference, we're again using moderate force going down into the beds, but then we're also pushing force into the fence. So what we end up with is kind of 45 degrees into where the fence and beds come together. So this time the board is a little bit more in front of you, but I still like the subtle shuffling of your feet so that you're never off balance. And then on the tail end of the cut, I like to give plenty of room beyond the blade for safety. We always joint our face first and then an edge because of the way that we reference things. That gives us a really, if this is our first face, this gives us a really, really strong reference. If we tried doing our edge first and then doing our face, we'd have far too much leverage and we wouldn't get an accurate 90 degree. The speed that we run our piece across the machine is called the feed rate. And the feed rate we want to use is not too fast, not too slow. Something about this speed is good. And steady is also good. If we go too fast, we end up with more defined machine marks and the potential for more tear out. If we go too slowly, we can get more burnishing and the potential for some burning, especially if we pause, which we want to try to avoid. As I referred to earlier, the cut depth, I usually stay between a 64th and a 16th. If you do too heavy of passes, you're more likely to get tear out and chipping, and it's a little tougher on the machine. If you do passes that are too light, there's not really a downside other than it'll just take more passes and it'll just take more time. So it's just kind of an efficiency thing. We want to use a moderate amount of pressure, moderate and even, especially on the front side of the outfeed table. We want nice and even pressure there. As we get towards the end of the board, we're primarily pushing forward with this hand and not as much down. If we're pressing too hard on the tail end as it leaves the infeed table, we can get what's called sniping, where the board just flexes a little bit and it makes a little bit of a deeper cut right at the end of the board. Very often when we are servicing a board on the jointer, we'll be resurfacing a board that has previously been serviced and has warped. Especially in that case, it's sometimes difficult to tell what are the new machine marks and what are the old machine marks. Just to keep track of where we are, I like to draw a pencil line on the surface that we're about to run over the jointer. That way we can tell the material we've removed and the material that we haven't touched. Something that we want to take into consideration when we're deciding which direction to send the board over is what the grain is doing. And as you can see with this board, it's pretty parallel through here, but then on this end it's going down pretty sharply. And it's doing the opposite on this side. It's going down sharply and then kind of flattens out. So the way that this cutter head is turning and cutting, it's rotating clockwise. So as we run the piece over, it's cutting the underneath. So if we have to choose between this and this, we want the grain going in this direction, not this direction, because it's cutting this way. Using this to illustrate my point, if the grain is going down towards the tail end of the board, this is an exaggeration of that. You can see it pretty easily goes over the blades. If we run this board in this direction with the grain going down towards the front of the board, then we're going to get a lot of tear out because of it cutting against this instead of cutting with it. This board is pretty straightforward when deciding which direction it goes over the joiner. Some boards, the grain will go up on one side and then back down on the other side, so it ends up being one side is good and one side is bad. Another similar situation is highly figured woods. Woods often have the grain doing some crazy up and down thing. If it's a mixture of up and down like that, and you can't avoid going against the grain, if you do really light passes, then it's going to make for cleaner cuts. There are several kinds of warps that we'll encounter that we'll use the jointer to get rid of. This board has what's called a cup. As you can see, it's touching the table nice and evenly along the edge, but then on the ends, it's not touching. So the board is shaped like that. So if we ran it over the jointer, we would first take material off of where I have it penciled in red, and then the next pass, it would be a little bit further in, and then the next pass, we'd lastly get the center, and then we'd have a flat face. This board has a defect called a bow, which means that it's warped from end to end, which means it's touching the bed nicely on the ends, but then the middle isn't touching. So as we run this board, we would see the ends get taken down first, and then with each pass, we'd make our way further and further up the board until lastly, we would get the center of the board. A defect that's a little more challenging than either the bow or the cup is a twist. And what we have there is two corners that are touching and then two corners that are not touching. So when we joint this, we would first pass, take off the high spots, and then with each pass, we'd work our way towards the center. Lastly, the blue. The reason that this is more challenging than the previous two that I showed was that the previous two sat pretty securely on the bed. This has a rock to it, and ideally we want to split the difference, which means we would want to balance it. This one's not that far out, so it would not be too difficult, but a board that has a lot of twists, you might even want to shim it just to split the difference to make sure that what you do is pretty even. If you have a cup or a bow, it's most often easiest to have the concave down as opposed to the concave up, because when you have the concave down, it's self-centering and sits pretty nicely on the bed. If you have the convex down, then you have rocking going on, either end to end with a bow or side to side with the cup. When dealing with a twist, I'll just see which side it sits a little bit better on, and this is definitely the worst side. It's all over the place on this side, and it moves just a little bit on this side. So I would do it with this face down. Once we have our nice flat face and we go to our edge, then we have different defects to deal with. We have different warps to deal with in this direction. So here we have the ends are touching and the center is not, and that is called a crook. If we have the same thing, but it's in a very small area, that's called a kink, but I'm not here to shame. If a board has a severe bow, there is the potential, if the pass isn't deep enough, that as the board goes off of the infeed table, it drops down a little bit and it can catch on the outfeed table. If there's a chance of that happening, what I'll sometimes do is, with the machine off, I'll place the severely bowed board halfway across like this. I'll make sure that the blade is not touching the board, because you don't want to start any of the machines with the blade touching the piece. If I know that it's not touching, then I'll start it here, turn the machine on, and then just drag the tail end across, turn the machine off, turn the board end to end, and do the same thing, turn the machine on, and drag the second end off, And what that'll do is it'll just take the same amount off of each end. And what we're looking for is that we have enough of a flat that it'll bridge from the in feed table to the out feed table. So usually just a pass or two will do it. And you want to do an even number. If you do this end, you want to do this end to keep the board balanced. And then it should go across without catching on the out feed table. The way that this machine cuts, it compresses the fibers of the wood just a little bit, and it also burnishes the surface just a little bit. So if we would joint a face and then later put stain or finish on it, it would really exaggerate the machine marks that are left behind on this machine. So you definitely want to sand the machine marks out after this machine before putting finish on it. There are a lot of people that will glue jointed edges together. If you sand them first, it opens up that burnishing a little bit, and it might make your joint last a little bit longer. Generally speaking, we don't want to run anything over the jointer that is less than 3/4 thick, less than 3 inches wide, or less than 8 inches long, unless we use more advanced techniques that I didn't go over in this video. That covers most of the basics for using this machine. If you have any questions about anything, ask someone who works here. Thanks for watching our video. See you next time.